Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about lattice energy and Born-Haber cycle. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime, and help to learn others. So this is the syllabus for Core 1 paper, Unit 3, Chemical Bonding. So let's discuss what is lattice energy and Born-Haber cycle and its application. So what is lattice energy? So the lattice energy U of a crystal is the energy evolved when 1 gram molecule of the crystal is formed from gaseous ions. So for example, Na plus, so that gas, and Cl minus gas, so that combines to give rise to NaCl crystal. So in this process, the lattice energy that we get, that is minus 782 kilojoule per mole. So minus sign means it is exothermic reaction. So energy is evolved. So this lattice energy cannot be measured directly, but experimental values can be obtained from thermodynamic data using Born-Haber cycle. Theoretical values for lattice energy may be calculated, and the unit of lattice energy is kilojoule per mole. So the energy changes involved in the formation of ionic compounds can be represented in cyclic form, and it is known as Born-Haber cycle. So formation of ionic compounds involves the formation of ions. So let us consider the formation of Mx solid or crystal. So M solid plus half X2 gas, so that give rise to Mx solid or ionic compound. So this is called delta H formation. So this is the Born-Haber cycle. So here M solid react with half X2 gas giving rise to Mx solid. So this is direct combination. So in this process, so that is called delta H formation. So similarly, this can process in a cyclic manner also. So M solid can also undergo sublimation process giving rise to M gas. So for this process we get delta H sublimation. Similarly, M gas can lose one electron giving rise to M plus gas. So this process is called ionization potential. Similarly, X2 can undergo dissociation to give rise to X gas. So this is called dissociation process. Similarly, X gas atom can accept one electron giving rise to X minus gas. So this is called electron affinity or gain of electron. So when we get M plus gas and X minus gas, so they can combine. So you can get combination of M plus and X minus. So in this process we get lattice energy for Mx. So giving rise to Mx solid or crystal. So in this process, if energy is absorbed, so that will be positive, and if it is energy is released, so that will be value will be negative. So the energy change in the above reaction is the enthalpy of formation. So that is delta HF. And the overall reaction can be broken down into following steps. So Na solid giving rise to Na gas. So that is delta H sublimation. And Na gas will lose electron giving rise to Na plus ion. So that is ionization energy. Similarly, half Cl2 will give you Cl atom gas. So giving it is dissociation energy. Similarly, Na plus plus Cl minus gas. So giving rise to NaCl solid. So this process is called lattice energy. And Cl gas will accept one electron giving rise to Cl minus gas. So this is called electron affinity. So delta H formation will be equal to delta H sublimation plus ionization energy plus half of delta H dissociation plus Ea plus U0. So delta HF decides the formation and stability of ionic compound. So if delta HF is negative, so the ionic compound form and stable. If delta HF is positive, so ionic compound is not formed. So for the formation of ionic compound, so delta HF should be negative and it should be formed and it should be stable. So next is application of Born-Haber cycle. So calculate the lattice energy for NaCl using Born-Haber cycle. The sublimation energy is 26 kilocalorie per gram atom. Dissociation energy for Cl2 is 54 kilocalorie per mole. Potential energy for Na solid equal to 117 kilocalorie per atom. Electron affinity for Cl gas equal to 84 kilocalorie per gram atom. And heat of formation for NaCl is 99 kilocalorie per mole. So we have to use this equation delta HF equal to delta H sublimation plus IE plus half delta H dissociation plus EA plus U0. So putting all these values given above, so we can calculate U0, that is equal to minus 185 kilocalorie per mole. Similarly, calculate electron affinity of iodine with the help of following data. Delta H formation is minus 68.8 and delta H sublimation is 25.9 and minus half dissociation equal to 25.5 and ionization potential is 118.4. Lattice energy is minus 165.4. So putting the data in this equation, what you will get? EA will be equal to minus 73.2 kilocalorie per mole. Please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveugpg.com. For class 11th and 12th, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.